First of all, what we have to do, first of all, we have to import the necessary libraries we will use. The basic libraries we have to use, we will import. Are you ready for, I think I will go a little bit slower because I want you also write at the same time with me the same code. I will import Numpy as MP. This is the alias we will use. I will import Pandas library as PD. I will import Matplotlib. This is a visualization library. .pyplot as PLT. This is general, is imported as PLT. And I will import another visualization library, Seaborn, as SNS. Right. When we run this one, yes. Now we have imported our libraries. This means that we can get our data into our notebook. How do we get the data? As we have learned previous tutorial, we will use just pd.read. But what we will read, I have sent you a data set, right? Salaries. You have to find the exact position of your data. After that, we have to find the pathway of our file. You can find a very short way. I will just copy this one. First of all, we have to write this is a CSV file, so we will read CSV file, and after that open brackets, and inside quotation marks we will just paste our address place pathway of our file, and after that we have to write the name of the file. The name of the file is position salaries, and also we will write the extension of the file, position salaries dot CSV, right? I will write here, and after if I run this, yes. There are two ways to write our pathway. One of them is just copy the pathway, but we have to write R before the quotation mark if we want to import like this. Another way is I will just copy the same code and paste here, and I have to change this symbol to other side like this. All of them. I have.
Can you give us some minutes to download the data?
I couldn't understand you. Can you repeat again, please?
Can you give us some time to download the data?
Yeah, of course, of course. If you are ready, just say, okay, we are ready. Okay. I think it is a zip file, and so you have to extract the file first, and after that you will just copy the path file of the file, pathway of the file. Now, as you can see, this is, if you write properties section, it will give the location of your file. This is I think it will be located differently, of course, in your machines, but this is my location. I just copied this one and paste it inside my code. This is the standard code. Read CSV. What kind of file you will read? You have to read CSV or JSON file. If it is a JSON file, I will just write it JSON file. But this is a CSV file, so I have to write here read CSV file. And now I use Pandas library. throughout using Pandas library, I say that I use this read CSV function inside the brackets, inside the quotation marks. I write the location of my file, and of course, this is the name of the file. This is location of the file, beginning from C to the salaries, and this is the name of my file. This is the name of my file. This is the extension, and this is a CSV file. Therefore, I use this CSV. Also, I will run this code. I write it differently. As you can see, both of them works properly. When you exactly copy your file and paste here, this sign will come like this, and Pandas will not read if you don't write here R. It will give you an error because I write here. I say Pandas that you have to read as the location of the file as a raw file, and it will transform this file from raw file into Pandas file. And therefore, if you use exactly copy your location of your file, you have to write before the quotation mark this R. And if you don't like, and you have to up and this symbol, but the same location, but I will just change this one. It's up to you. And after that, I can use this one or other one. I will just assign this one to a variable name because I will use variable. Have you downloaded your file? Are you ready?
Yeah.
Okay. Now the second step is, after I have imported my file either from an internet source or from my computer, I have to read this CSV file, and after that I have to assign to a data frame a variable name. It's up to you. You can choose either of them. You can say salary as the name of file, or I mainly use the short one because Pandas use data frame. It's a tabular form, and I just say it's short with df. It is up to you, right? Yes. And after that, if I run df here, run this code, because I have not yet. Yes, this is our file, right? First of all, I aim to begin with a very short and easy file in order to make you understand how this messaging algorithms work, and in order to make you understand better about our file. Yes, this is, as you can see, these are the positions of people, employees, business analyst, senior consultant from the CEO. These are the salaries of these people, right? What I will do is, first of all, you can predict the salary according to the level and position of these people, or you can predict the level of people from the salaries of the positions. It is up to you, but mainly we will predict the salaries of the people. In order to do that, we will use for machine learning algorithms. And first of all, I have to say this. This is a regression problem because we will predict salaries. We have to make distinction between regression and classification. If I will also present you a classification problem. In classification problem, for example, is this tumor is cancer or not? Is this true or not? For example, when it comes to salary, is this salary high, medium, or low? This is a classification because our data is categories. But in this data set, my target column, we say this my target column is numerous, right? There can be any number. It means there is no category. Therefore, we will use decision tree regression algorithm for this data set, and The second step is, this is a very short data. There is nothing to do with this. There is no missing values in this data set, right? So there is only one categorical data in this data position, but they are already represented in the level because business analyst as labeled as 1, junior consultant labeled as 2. So this is a give extra information but for my machine learning algorithm, I don't need this one, right? So we will use X and Y as variable name, but you can use either of them. But it's, for example, if any other developer read your code, if you write here X, he will understand that yes, you are assigning the feature of the data to the X variable, and you are assigning the target variable to Y variable. And first of all, I will assign the features, positions, and levels to X variable, right? But as I said before, we don't need this one because it is already represented here. The machine learning algorithms do not read strings. So we have to transform these strings into numerical values, but it's already represents numerical values, so I don't need that. I will just assign, first of all, I have to show this. We can say, as we have learned previous lecture, how can I select this column, this column, level column, with all the rows? I will use ilog function or method. Inside this method, as you understand, we will write here the rows. We will write here the columns. But if rows is represented in the left side of the comma, and columns is represented on the right side of the comma. So I will choose all the rows because I have to select all the rows. But when it comes to columns, I will choose only which column I will choose, not the 0. The index begin with the 0, not 0. I will begin from the first one, right? I will begin from the first one, but I will not select the salary because this is my target variable. I will exclude this one. In order to exclude, as you remember from the Python list, I will just minus n right here. Then it will start from 0, not 0. It will start from the 1, and it will stop with minus 1, right? When I run this code, as you can see, we have selected levels, right? But we will not present this value as a Pandas data frame. We will send this to machine learning algorithms as Numpy arrays. In order to transform data frame into a Pandas arrays, I will just write here values parameter attribute. I'm sorry, we say values as attribute. As you can see, now we have selected from the data frame the level column. These are the features that I will feed the machine learning algorithm, and I will choose these as not Pandas data frame but Numpy arrays, right? And I will assign this into my X. This means to my feature. And I will do the same thing for the salaries. Now I will select the salaries. I will do the same code, ilog, close bracket, right? I will choose all the rows. So this means, as you remember from the Python list, it will begin from the first one to the end one. So all the rows will be included. But for when it comes to columns, I will begin from the 0, 1 to the end of the column, right? And if I run this, it will provide me a Pandas data frame, but I have to transform this into Numpy arrays. These are standard dot values. Will transform this Numpy arrays because I will feed my machine learning algorithm from the Numpy arrays, right? And I will assign y variable here. Should I wait? Are you ready? Yes. In order to, we can check the size of our data. We have not selected. Yes. Yes. These are my features is represented by X. The shape of this means there are 10 rows and 1 column. The shape of my target column is the same, right? 10 rows and 1 column. This is very simple data because I want you to understand how it works. So I just choose for the first time the very easy algorithm, easy data set. Yes, this after we have implemented, we assigned our data into features as X and target column to Y variable, right? And as you can see in my X or Y, when I run this, it is this X, right? There are no missing values. So it is ready for machine learning algorithm, and there is no categorical and strings values inside this one. So I will just, the next step is just call my machine learning algorithm. How we call? From scikit-learn is the main library for machine learning algorithms. There are, I think, almost more than 100 machine learning algorithms in this main library. And decision tree algorithms lies in the tree. This is the subset of this library. In the tree library, in the subset of tree library, I say that from this main library and from this inside this subset of this tree library, please import decision tree Yes, when you write your code, if you push the tab button, it will automatically show you and what kind of algorithm it involves, right? There are two types of algorithms for decision trees. One of them is decision tree classifier, the other one decision tree regressor. Because this one is not a classification problem, I will choose the regressor, right? When I run this code, I call the algorithm, right? The next step is to create an instance of this algorithm. I will just name decision tree in a short way. I will call the algorithm after importing decision tree regressor with open brackets, right? Now I called the decision tree regressor algorithm, and I created an instance of it because every time I don't want to write this very long sentence, so I will just assign it to this d3 variable. And after that, I will fit my data, right? Decision tree dot fit function. And after that, first of all, I write the features of my data. The feature is represented in the X variable, and after that Y variable. That's done. That's it. Now, all the professor try to tell you throughout the lectures will be done on this just one single code. The algorithm will go through these simple features and try to predict the best hypothesis or best function that fits to predict these salaries, right? It's everything is going on behind the screen, and the machine learning algorithm will do everything we need. And after fitting, now our algorithm is ready. Fit the variables, and now we have a function. We can make predictions for the future variable. For example, when I want to predict, for example, right, 1 for example, decision tree, but we have to write decision tree dot predict. In order to make prediction, we have to use predict method. Yes, it's of course it is very, when I call the algorithm, my data frame here, as you can see, I commanded to the algorithm, my algorithm, to predict the 1. If you get a feature 1, what the algorithm will predict is a salary 45,000. We come here, yes, it is the salary of 45,000. Yes, it's predicting good, but it is the data itself, so of course it will predict. It's already trained with this data set, right? So also, for example, if we can predict another one, decision tree dot predict, right? Why I write is 2 different closed brackets, because the data is represented it's a 2-dimensional data. So I have to, when I use the data, I have to use 2-dimensional data in order to predict it. So in order to inform the algorithm that I have 2-dimensional data, we have to write 2 closed brackets. And for example, 6,5, right? This is not in our lists. What will it predict? It will predict this 150,000. I call my data frame again. As you can see, it can assign to this 200,000 or 150,000, but when I call the predict the 6,5, it has predicted as this salary, right? And it is also very important to make some visualizations. Maybe later, but to this point, have you write the same course? Are you ready for this point? I think you are ready. Let's make a good visualization. I think you will understand better. PLT is a visualization library. Figure. I will assign fixed size. This will decide the size of my figure. Yes, I think this is enough. I will use Matplotlib scatter. This will create a scatter plot, right? I will assign my X. These are features of my data. These are and Y. This is my. It will scatter between X and Y. The scatter plot between X and Y, and we can add a color parameter also. You can write either column. For example, we can say this yellow, right? And after that, We can say plt.plot. We will just create a list of 10 numbers, right? Range 10. And yes, I will assign these predictions. I have to get my predictions into not this one. Yes, we can write here also. Yes, range, and these are my predictions, right? Predict X, and color, I assign color blue. If I didn't wrong something, I think it will. Yes, not that color. There must be a comma. Yes, this is the visualization of. Maybe we can make it a little bit much more good. plt.x x label. These x label, this means x line, right? These are positions. This will also represent the positions. plt.y label will label y here, and this is my target or my salaries. I will name this one salaries. Not yellow, I think green is better. Green, right? When I run this, do you see that? This is the positions, right? These are the salaries. This line is my predictions. This is the actual data. Actual data is represented by these green dots in the figure, and this is my predictions. This is the predictions of the algorithm. What the professor wants to try to overfitting, right? I used 100% of my data for training set. As you can see, it is overfitting. It means that my prediction lies over or under it, both of them. Not over the original data. So yes, the next step is this is very simple, right? One line of code. If your data is ready, we can go step by step in order to make you understand better. We have imported our data. We use this function. After downloading it, or you can also import your data from an Excel file. In your assignment, there is an Excel file. You can create your Excel file and just write here Excel. Of course, you have to change this extension of your file, right? XLSX CSV. And after that, I assigned my what I have read by Pandas assigned to FDF variable. So I have just run this code in order to see what kind of data I have. And after that, the next step is, because all the data is almost ready, there is no missing values. So I just assign to X values the features of data. This is level. And y, this is my target, the salaries. I want to predict the salaries according to level of these employees, right? This is my problem. And this is how I can select. And after that, we just, after I assign that x, y, and y variables, I just simply import my machine learning algorithm. What kind of machine learning algorithm you have to use? You will use this decision tree regressor because, as I said, the salaries is a continuous value. So I have to use decision tree regressor. If it was a category, for example, salaries between, for example, high, medium, low, I have to select decision tree classification algorithm. And after I importing my decision tree regression algorithm, I just created an instance of this one because this is very long, and I just assigned this algorithm. I said that please Python this, I will assign this algorithm into this simple variable name. You can name it whatever you want. You can say whatever you want to name it. It's not important. It will work. I simply say it decision tree, D tree. And after that, after creating an instance of my decision tree algorithm, the next step is to feed my data. This is the crucial point. This is the point your code, the algorithm will fit your data. I say that after feed decision tree dot feed, I say that these are my features and these are your target. The algorithm automatically is already designed to understand these are features. If you, for example, write here y, also x here, it will be confused. It will evaluate x as your features and x y your features and x your target column. So you have to be very careful. First of all, I will assign the feature first, and after that the target, right? And now it created a simple function or hypothesis according to these x features in order to predict this y target data, right? And after that, my algorithm is ready. I can just predict any kind of data I have. For example, I try to predict, for example, 1, and it predicted this 45,000, right? And the next step is I just, in order to visualize it, I just created an figure. Plt.figure creates a figure, but this figure is very is an empty figure, right? And after that, I say that please inside this empty figure, please create a scatter plot. Scatter plot means you will use data on your x line and your target on your y side, y line coordinate system, and it will create dots, right? Whatever x will match with y, it will create a dot here. For example, number 4 position match with here, right? And after that, I created another plot. This is the plot of my prediction, and it is a line plot. I assigned numbers from list as a list from 0 to 10 because I know that it begins from 0 to 10, right? So I just write a simple list of Python. And after that, this will be my y line. So this is my predictions. I will predict for this time all x data set because I want to compare the true values, actual values, and with my prediction. These are the predictions of the algorithm. And these are simple, the whatever you like. These are parameters, the red color and x label. This will label these positions. You can write anything you want. And y label, plt y label function will label this y line in the coordinate system. Is it understood to this point? Yes, I hope so. This will be a little bit long code, but I think it will help you better to understand my point. I will call SNS. This is a Seaborn library. Set style. I will just decide what kind of style I have. Dark grid. This will create a dark grid of figure. In order to make a good visualization of your data. The same thing, plt.figure. I use the same size, fig size. You can always use the same. For example, if I can say 20 by 10. 20 decide the length of your figure, and 10 this height of your figure, right? So I assign 2 times higher than the height of my figure. It's up to you. You can choose, for example, 10 to 10. It's not important. Yes. I will create any variable grid. np.arrange. I will create a Numpy array. Range. I will say that use minimum value of x. Begin from the minimum. I will create a new Numpy array and assign it to this grid variable here, and to maximum value of x, right? To x. And this is my step. Please go step by. Oh, this is the step. As you can remember, arrange is a creation of my own Numpy array, right? I just want to create a new Numpy array, and I will use this array in order to make very good predictions, in order to test the evaluation performance of my machine learning algorithm, because this data is already trained by the algorithm. It already knows that if the person is the level 1, it has to get this salary, right? It is not so much meaningful, but in order to simplify it, I just tried to show you. But this time it is a real test, because I am creating a data set, a Numpy array, beginning from x, minimum of x. This means 0. You can just say this 0, or the maximum value is 9, right? You can choose 9. It's not important, or maximum x. It will return to you maximum value of x. This is my step. It will start from 0, 0, 0.01, 0.002 until this is the end of my array, right? Grid. I have to reshape my grid, because this will produce me an one-dimensional array. I have to reshape this one. I have to reshape, as you can remember from the Numpy lectures, tutorials. Len grid, the length of the grid, and 1. Yeah, now I have reshaped. I think this will be very long. It will be confusing for you. If you want, I can continue to do, but Now I'm thinking that it will be a little bit complicated for you, so because it's very long code. Okay, we can just continue. Scatter x. This has two values of x color equal red. I will assign color red. I will create more than one figure here. This is the original data, right? I will show is in this figure also. Also, I will plt.plot another. I will creating another plot grid and decision tree. This will be my x line here. These grid, these numbers that I have created from 0 to 9 by stepping 0.001 will be my x line, and this will be my predictions. That predict grid, right? Not read grid. Yes, and I will assign color as blue. Yes. plt.show. Yes. Now, maybe we can assign also. We can show also plt.x label. We can also name our labels. X line is positions. Positions of workers here. Workers. And I'm sorry. plt.y label is the salary, right? This is my target. I will run the same code again. As you can see, these are my positions, but for this time, I have not used just 1 or 2 or 3 the actual values. I have used this Numpy array, this function. What does this mean? Maybe you will understand better here. Yes, I will use just this data. It started from 0 position. I know that it is the end of the end is 9. From the 9, by stepping 0, dot 01. Okay, maybe and this is our step. As you can see, this is first step, second step, and we have used for our predictions here. For our prediction, we used grid variable. Our grid variable is this one. This means this is our grid variable. This is what the algorithm wants to predict it. If you, for example, use 0, it predicted this value. And for 0,011, this one, right? And it is going up, rising up to position 9. As you can see, if, for example, in this line, for example, from 4,5, I think, to 5,5, it predicted this value, and it's predicted accurate, right? These red lines are the actual positions of my original data. Position 5 will get this salary, and the algorithm predicts very good. I have to say that the decision tree works very good if we have fewer than 4 features. This predicts very good, but if we have more than 5 features, the predictions are not so good. There are very good other machine learning algorithms that predicts better than this one. Yes, this is a good step, and what the professor tried to teach you, we will show here with code. Now I import from Scikit-learn. This is the main library for machine learning algorithm. It's all the tree library. I will run this one. I want to show you if you, for example, tree. Now I use this library from tree. Print tree dot export. This tab export text. If you press the tab, it will show the function available functions. I will use text, and I will use my decision tree algorithm. This will show me how the algorithm is making its own tree, right? For example, if feature 0 is minus, or for example minus than or minus or and equal than 8,5, and these are the features. This function shows us how our algorithm making its predictions, right? How it is creating its decision tree. We can, I think this help you better. For example, if a feature is bigger than 2,5, the value is this 6,000. Can you see that? If feature is bigger than 2,5, the value is 8,000. The machine learning algorithm, this decision tree teaching itself, okay, creating these lines of trees, branches or leaves, and assigning values. If the feature, for example, we have just one feature, therefore it's always use feature 0. If we have had another feature, for example, feature 1, feature 2, it will also create another tree for feature 1, feature 2, and it has been created its own tree and assigned values. It comes from, this is the main tree, I think, the root tree, and after that this is another one. This is main tree, root tree, right? Yes. If it is fewer than 8,5, it follows this direction. If it is bigger than 8,5, it will follow this direction, which means that it again is creating another branch and node, we can say. If it is smaller than 9,5, the value is 500,000. If it is bigger than 9,5, the value is 1 million, right? And if it is smaller than 8,5, these are positions, right? The features are positions of the employees, and it will create another tree. If it is it smaller than 6,5? Yes or no? If it is, for example, if it is bigger than 6,5, it creates another node. If the algorithm asks again, is it smaller than 8,5? Yes. If it is yes, it will assign through 200,000. If it is bigger than this one, it assigns 300,000. Do you understand better, right? With this, because our data is very simple, so you can understand better. These are our labels. These are features what we have learned. This is what our algorithm have done. Yes, we can create a very good visualization also of this one, and after that I will take a break and go to classification problem. Fig, I am creating another figure. PLT, every time I use this one, I am creating a figure. You have to learn how to create figures. We haven't had enough time because I aim to also show you Seaborn and Matplotlib libraries, because when you work somewhere, nobody will understand these numbers. Only the coder, only the programmer will understand. You have to visualize your outputs, right? So in order to visualize, we need visualization libraries, and these are, I think, the best ones: PLT, Matplotlib, and Seaborn. Very simple, and we can very easily take the exact results in a short amount of time. I assign fixed size, maybe the same figure size. If I am fast, please tell me. 3 dot plot. I will. If you want to make a plot something, it will create a figure of something inside these brackets, and inside these brackets I will just give the values. I will give the my decision tree classifier algorithm, the instance of it, feature names. These are parameters inside this one, and you can look at the documentation. This is the features is my labels, right? Levels, and yes, and after that, comma, I need class names. Also, these are parameters you will find in the documentation of plot. I assign these salaries, not salaries, salary. The name of the column is salary, and comma, and I will use another parameter field. I want to field version of this, so I will assign boolean value true. Yes, I think everything is ready. What is the wrong one? plt.figure. Decision tree, feature names. Maybe we can see better than here. Not levels, we have level. Salary, right? Yes, these are the problems. I'm sorry, not plot tree. Yes, I misused the name of the function. Not plot tree. Yes, as you can see here, this is the actual visualization of this data set. As you can see, this is the root of root node, right? It assigned 8,5 as the division point, as the main division point. And if it is smaller than, if the label is smaller than this one, it's going this direction. And if it is bigger than this one, it's going this direction. And as you can see, number of samples is 10 because our data set is about 10 rows. So if you have more than 10, it will show you 100 or 1000, how many it is. And after that, it is using main square error function in order to get errors and get and correct these errors. These are also, it's also shown in this figure, right? If it is bigger than this one, the value is it assigned here, right? And if it is smaller than this one, and it is making another one. If it is bigger than 6,5, and it is going this right direction, it is smaller than 6,5 position level, it's going, and as you can see, it is assigning the values right here. Is there any question to this point? Because I will take a break and we will go through a classification problem, and we will use how decision trees for classification problems for the next tutorial. We can go through another one. I want to understand better. Steps are simple. First of all, I am importing the necessary libraries. You have to import just simple. By using them, you will memorize them. First time it can be seen a little bit complicated, but when you use again and again, you will get used to these codes. And after that, I am reading my data, whatever source it is. I am reading from my computer. I just writing the location of the file and the name of the file with its extension, file extension. It's a CSV file, therefore I use read CSV code here. And after that, this is my data. It's very simple. There is no missing values, so therefore I can easily, I say that I assign the features from the level, this level column as my features, and the salaries is my Wi-Fi. This means it is my target. This is what the machine learning algorithm will predict. Okay, these are some function methods. You will get information about your data, 10 rows and 1 column. This is the shape of my data. It's the one-dimensional. It's the two-dimensional. Yes, we can see that it's a two-dimensional array, and Y is two-dimensional array. And after that, because my data is ready, no missing values, no categorical values, I just simply call my machine learning algorithm, right? Because it's a regression problem, I am calling regressor, decision tree regressor algorithm. And after that, the second step is very simple. I'm just creating an instance of this machine learning algorithm. And after that, the next step is just I am fitting this algorithm, this instance of this algorithm, to my actual data, to my training data. I will use all data as training set because data is very low, is very small. But for the next section, we have very long data, so we have to train and we have to make a train and test section of our data, and I will show you this one also. So our algorithm just fit our X features and try to predict a best model, a best hypothesis, or a best function that connects X features to Y target values. And after creating this function, it means it will use this function to predict any value you enter here, right? After this step, it has already a long step of algorithm, and will create a good function, best function that fits from X file that connects your X features to Y target values, right? And after that, I'm just making predictions. You can predict single values either, or we can predict more than one values. For example, there are in this set there are more than I think 100 data, and it will try to predict correctly, right? As we can see in this visualization. Visualization can take time, but I have to use this visualization, because I think you can see and understand better with this visualization. And after that, what the professor tried to teach you throughout the lectures, this code is already showing you how your algorithm is making its nodes, its branches, its branches according to your data, right? And as we can see, this is our main branch, main dividing point or root node. If it is bigger than this one, it is going this direction. If it is smaller than 8,5, it is going this direction, and it is making another decision, right? And is it smaller than 6,5 or not? If it is smaller, it is going this direction. If it is bigger from 8, as you can see, this is this one, and this is this one. This is the division point, right? The division comes here. First step here is smaller than here or bigger than here, and after that it comes this section. Is it bigger than 6,5 or smaller than 6,5? If it is bigger than 6,5, it's coming here. And if it is smaller than this one, it's going this direction, making another nose. But this is what we have to worry about, because the algorithm already know and do this. But I am explaining to you to understand to teach you how the algorithm works properly. And this is a very good, I think, very good visualization of the algorithm, how it has divided our original data, right? We can easily see how the algorithm, you can basically use the same code here without any changes, but for the feature names, this have to be changed, because it will be changed according to what kind of data you have. These are the column names. In this column names, my feature is only one column, so it is the level, right? As you can see here, TF. This is only my column, and I assigned here this one, and salary is my target, and I assigned this one here. Field means it will fill these square shapes.